Okay, so we started this journey in grade 10, but we are going to behave as if we know nothing. So we're going to work together all through. All right, so let us start with what analytical geometry. When we talk about analytical geometry, we're going to talk about the geometry of coordinates. The geometry, which is a study of coordinates. Now, your coordinates are always x and y. So your coordinates are written as x, y. Some time ago, some examiner used the word abscissa, which is what we use as our x value. That's no longer necessary. So when we write our coordinate, we write it in bracket. The first one is x and have y. Now, there are very, very important things we are going to do between two coordinates. Very important. The first one, gradient. Gradient between 2 points. All right, so each point has its own coordinate. Let's start with the symbol of gradient. Symbol of gradient is M. Take note, small letter M, please. Small letter M. Gradient is small letter M. We're going to look at the gradient of a line. Okay, the gradient of a line. Now, types of gradient. Before we start looking at how to calculate gradient, types of gradient. Okay, number one, we're going to have a line that is going this way, right? Number two, we're going to have a line going this way. Number three, we are going to, okay, I want to do this in such a way that line going that way, a line going this way, a line going that way, and a line going this way. The first one is, you can see the direction is going up. All right, so this gradient is positive. Positive gradient. I'm just going to say positive there. This one is a negative M. We're going to prove all of this. If it's a vertical line, the gradient is undefined. And here we have a zero gradient. So take note of that. When I say positive, it means it is increasing. Negative is decreasing. Undefined is undefined, and a zero is constant gradient. So decreasing, increasing. Here, M is greater than 0. M is less than 0. And M is equal to 0. So basically, you would see we are going to focus on 3 of those because one of those does not exist. Positive, which is increasing. Negative, which is decreasing. Constant, which is a 0 gradient. All right, are we ready, everybody? There are 6 things I want us to look at when it comes to gradient. Concepts of gradient. 6 concepts. Concepts of gradient. There are 6 of them. Concepts of gradient. Number one, gradient is the change in y, but the change in x. y2 minus y1, but x2 minus x1. We know that from grade 10, and that's again we know from those of you that are doing physics. So I want us to quickly check on a few things. For each concept, we'll quickly look at an example. Find the gradient. Find the gradient between 2 points between point A and point B grade 11 or from grade 10. I'm sure we know how to do that. You want to walk through that for me to give me answers? Negative 3 over 4. Right. So this is how I like to represent my own. Since gradient is small letter m of AB, I'll say YA minus YB over XA minus XB. What's the Y value of A? Minus, what's the Y value of B? Negative 1. The X value of A. Right, I hope that makes sense. Y value of A, 2 minus 1. Then we have what? 3. No. Why am I saying minus 1? Y is 2 minus 5 minus negative 1. 3 over 4 is a decreasing function. Is a decreasing what? Function. Are we okay with that first one? All right. So that's our first concept of gradient. Number 2, we can get gradient from the equation of a line. From the equation of a line, which we know from grade 10, y is equal to mx plus c. But you can only do that after writing it as y equals to mx plus c. Right? You can only do that after writing. So for example, if I give you y equals to 2x plus 3, it means my gradient is positive 2. Right? But if I give you this, 3x plus 2y minus 6, let's say minus 5, equals to 0. Please work out your gradient for me. Remember, we do change of subject. Write it as y equals to. Give me an answer quickly. All right. Sorry. What's your answer? Right. Sorry. What's your answer? Just lost network there. Quickly. What's our answer?
-3.
How did you get -3? -3 is wrong. -3 is wrong. Let's make y the change of subject. Let's do change of subject. Yeah, now you're talking. Because if I move everything over, I'll have 2y. Okay, I'll check that message now. Yes, there's a hand. Then I'll divide everything by 2, which means my m is equal to -3. Are we okay there? It's very, very, very important. Concept number 2. Now, concept number 3 on gradient. Concept number 3 on gradient. There's something we call parallel lines. Parallel lines have equal gradients. So if two lines are parallel, then their gradients are the same. Saying the gradient of AB is equal to the gradient of CD. Why? Because AB parallel. Let me give you a quick question here. I want to check something, whether you can apply using your grade 10 knowledge and now. Okay, if I were to tell you, if I give you two lines, and I tell you that these two lines are parallel, okay, and then I give you this. What will be the value of y here? Let's do the maths. Apply what you learned in grade 10 and simple maths. Right? We can share answers.
Y is 4.
Y is 4. Okay, Tariq is giving me 12. Who else has an answer? Given is giving me -3. Junaid is giving me 4. Why are we having so many different answers, guys?
It's 12. Miriam is speaking, it's 12.
12. Junaid. Given. Why are you guys giving me those answers? If these two lines are parallel, it means their gradients are the same. So why don't we therefore first look for the gradient of the first line? All right. So let's call this AB. Let's call this CD just for labeling sake. All right, quickly. Gradient of AB, that YA, YB over XA minus XB. What is YA? The Y value of A is 3. The Y value of B is 7. What is the X value of A? 2. X value of B is 4. What would that give us? +2, I think. Good. Then we go to the next line. ED, YC, YD over XC. But these gradients are the same. So I already know this as 2. What is the Y value of C? 8. What is the Y value of D? Y. What is the X value of C? 5. And what is the X value of D? 7. We now do simple maths. 2 equals to 8 minus Y over -2. Cross multiply. 8 minus Y equals to -4. Negative Y, move the 8 over. Negative Y is -12, and Y equals to 12. Junaid, where is your 4 originating from? Kevin, where is your 3?
So, I simply put the wrong sign.
Okay, Kevin, where is your -3 coming from?
So what's the previous question?
Give me the previous one. Oh, you didn't. Okay, you didn't answer. But all right. Okay, it was the previous. All right. But are you okay with what I did now? Please, when two lines are parallel, thank you, Yad. When two lines are parallel, then their gradients are equal. And you will see this. We're going to talk about a parallelogram, a rectangle, a square, basic shapes that we did in grade 7, 8, and 9. All right, number 4. What is our fourth concept on gradient? What concept will be perpendicular lines? Perpendicular line means that they have an angle of 90. If two lines are perpendicular, the product of their gradient is -1. I have two lines that are perpendicular. Remember, the word perpendicular means that the angle between them is 90 degrees. I have A, B, and C. Means the gradient of AB times the gradient of BC equals to -1. Product of their gradient is usually what do we do? Given one gradient, what we do is, given one gradient, change the sign and reciprocate to find the other gradient. Given one gradient, change the sign and reciprocate to find the other. We have point AB, line AB and BC, and there's a 90 degrees angle. That is the perpendicular lines. So let's put this here. 90 degrees must be between them. Perpendicular. So I can find the gradient of AB quickly. YA, YB. We're going to do this over and over again. So when we start calculating, no one is lacking behind. Y value of A is 7. The Y value of B is 3. The X value of A is 4. And the X value of B is 2. That is 2. The gradient of AB. I don't need to do any magic. All I need to do is, how do I get the gradient of BC? Remember small letter m? It says, given one gradient, change the sign and reciprocate. So you see I have a positive. I'll change it, it becomes a negative. This is 2 over 1. Becomes 1 over 2. Done. So that when I multiply those two, I should get -1. 2 times -half is negative. Can you quickly write that? I want to give you one to do for me. Q, -7, -2. Find the gradient of ST. We have a 90-degree angle between them. It means they are perpendicular.
Negative 5/4 is the answer, sir.
Negative?
5/4.
Okay. Can everybody please share answers?
David, take your
Please, let's share answers. Let's talk. Consistent practice is important. The answer we can say, I want us to do it in small bits. So when we look at a question together now, it becomes a lot easier. Yad is giving me negative 5/4, just like Mandla. Given, Bonolo, Junaid, Tariq. I'll appreciate answers. And remember, you should know me by now. Even if the answer is wrong, I want it. Just share with me. And if you are stuck, also raise, I'm stuck, sir. I don't know what. Nolo, you have 5/4. All right, let's quickly calculate. Okay, I see you've changed it. Let's calculate the gradient of QS YQ YS over XQ minus XS. I just like to write it like that so that it's easy for me. All right, what is YQ? The Y value of Q is -2 minus the Y value of S is 6. X value of Q is -7 minus 3. What will this give us? It would give us a -8 over -10, and which is 4/5. Lovely. Okay, guys, you are correct. Now we change the sign and reciprocate. Beautiful. Beautiful. All right. Number 5. Collinear points. You see, we are still on gradient. Collinear points. Points on a straight line. That's what collinear. Collinear means together. Linear means straight. So points on a straight line. And what does this mean? All right. Gradient between any 2 points. Gradient between collinear points are equal. If I have that, A, point B, and point C, the gradient of AB will be the same as the gradient of BC. It's also the gradient of AC. Any 2 points there will give me the same answer. Any 2 points there will give me the same. Let me cook up a point for us. Let me cook up a point. So an examiner will do this for you. Look at what they will do for you. Let me give you point A, -3. I'm just going to quickly do my maths. 9. Let's say this is X. Let me look for a y value. And I have a 0.99 here. And I say find the value of x. Do you want to try? Those are co-linear points. Don't worry, it's going to work. I've done my maths. Yeah, it's going to work. Find the value of x. Using your knowledge of co-linear points, the gradient between AB is the same as the gradient between BC. Let me see how you're going to interpret and the gradient of AC. Quickly, that should take us about 3 minutes. Then we will be done with gradient. Oh, we have one more point. I said there are 6. Yes? I don't think it's 0, Tariq. Please check your maths again. Manolo says she got 3. Can I get other answers, please? Everybody.
3.
Got 3 as well, Mandla. Kevin got 3. All right, let's quickly work it out. I don't think it's a 0. I know that the gradient, you see, I can calculate the gradient of AC, which makes it a lot better for me. So we can get the gradient of AC because we know those points, YA minus YC over XA minus XC. What's the Y value of A? -9 minus the Y value of C, 9. X value of A, -3 minus the X value of C. What do we have? -18 over -12 over 12. All right. -9, just making sure. All right. And that will give us what? 9 over, or we divide by 6 over 2. But then I know that it is the same gradient. I can use either AB or I can use BC. Gradient of AB, IA minus YB, XA, XC. What is my gradient of AB? It is the same as AC. So 3 over 2. What is the Y value of A? -9. Y value of B is 0. X value of A is -3. What am I using again? B. Why did I write C here? The X value of B is X. 3 over 2. All right, this remains -9. We cross multiply. This is going to be 3 times -3, which is -9. All right. Minus 3x, -18. So let's do the algebra nicely. -3x equals to -9, and x is 3. Tariq, are we on the same page? Oh, you fixed it, 3. All right, so beautiful. So guys, let's go gradually. We're combining all of these things together. Number 6. Angle of inclination. Now, so from 1 to 5, we did in grade 10. Now, this is the new one, and we'll take to grade 11. The angle of inclination is measured, the angle of inclination, theta, is measured from the x-axis in the anti-clockwise direction. The formula is that tan theta equal to gradient. We're going to look at 3 concepts here quickly together. 3 quick concepts here together. A, positive gradient. So we're going to have our y-axis and our y and x-axis, and I will draw a line here. Line doesn't matter. Theta measured from the x-axis. Remember, a gradient there is positive. Let's cook up a coordinate here. -1 and -3. 3 and +3. E and Q. Find theta. Let's draw that. All of these things, you're going to see them now. They are going to come into play all at once in one question. So let's move on quickly with the theory part. We can get all the theory done now. It's so nice. This you will now find in question 3 if you look at a grade 12 paper. Okay, so what is MPQ? And if you notice, I am trying to repeat the issue of calculating gradient in every question so that we master it. No room for error. What's the y value of P? -3. Y value of Q? 3. X value of P? -1. And the X value of Q? 3. Positive answer. We need to keep that expectation. -3 over -3 minus 3 would be -6 over -4. And our answer would be what? 3 over 2. And for theta. So you would notice theta stops at that line PQ. Right. So tan theta equals to the gradient of P. That's the line with which it connects. So tan theta equals to 3 over 2. What is theta therefore? It's the arctan of 3 over 2. That's grade 10 as well. Finding the angle. Three over 2 is 6,31. Talk to me. Are we okay? You're going to do an exam. You're going to do yours shortly. Ify. You're going to do yours shortly. So please make sure you are seeing it. The positive. Now, NB. A positive gradient gives an acute angle of inclination. Acute means it must be smaller, 90. That is, theta is less than 90. Theta lies between 0 degrees and 90. Ooh, this note is so beautiful. Theta lies between 0 degrees and 90 degrees. Let me know if we are okay, everybody. Theta lies between 0 degrees and 90 degrees. I want us to see how this will change if theta is now negative. I want us to see how this will change if theta is negative. Are we ready? Let me know. Quickly give me responses. Are we ready to go to the next one? Viewer, I'm not sure if we're on the same page. Right. B, negative gradient. Negative gradient. There's something we did on general solutions which we are going to bring in now. Did something on general solutions. I want to put it here because some of you think it's negative because it's on that side. It's negative because of the direction. Now, where is my theta? We start from the x and we go anti-clockwise. Start from the x and move anti-clockwise. clockwise. So let's call this U and call this V. Let's cook up a coordinate there, 3 and negative 5. And here let's cook up negative 2 and positive 5. And I want us to see what's going to happen, that we make a little note. Everybody, please get me the gradient of UV. I want an answer from you. Please, everybody, get me the gradient of UV.
Negative 2.
Negative 2. Okay. Can we confirm? I need confirmation. You're confirming that it's negative 2? You also confirms that it's negative 2? Bonolo given. Zurich, are you getting negative 2 as well? All right, so again, YU minus YV X. Please, the order is very important. You see, I'm saying UV. So we have to maintain that. What is the Y value of U? 5. What is the Y value of V? Negative 5. What is the X value of U? Negative 2. And what is the X value of V? 3. All right, what would that give us? 10 over negative 5. Perfect. And you can see from our first line, we described it as a negative gradient. If you go to the first thing I described, negative gradient. Okay, beautiful. Now, watch this. Tan theta equals to m. So what I do is I like to trace. Can you see from the x? Trace. Poop. Which line? UV. So tan theta is the gradient of UV. All right. What is my gradient? Now let's go back to general solutions. I told you that the negative tells you about the quadrant. The negative gives you the quadrant. That's what we're doing on the general solution. So let's keep the same information. Quadrant. So we repeat. And where is tan negative? Tan theta is negative. Talk to me. Which quadrant? Where is tan negative? Thank you, Bonolo. In quadrant 2 and 4. Quadrant 2 and 4. Please get through the general solution lessons, please. It's really going to be of assistance to you. Here we said it is reference. Here it is 180 minus reference. Here it is 180, just rewriting all of this. Here it's 360. All right, guys, we are always going to be working in this quadrant. Just quadrant number 2. Always. They're going to work here. So how do I find my reference? We forget the sign now. We just say arctan of 2. Forget the sign. That's what we're doing when we do general solutions yesterday. Please, if you missed it, let's catch up quickly. We're running time is, against us. What do we have? The 3,43. But we are in quadrant number 2. Theta, therefore, is 180. Remember, we're in quadrant 2 minus your reference. What's your reference? My reference is 63,43 degrees. And what's your answer? (180 minus 63,43) is 116,57. Now, nota bene, negative gradient gives an obtuse angle because we are working in the second what? Quadrant. Our angle must be between 90 degrees and 180. Our angle therefore lies between 90 degrees and 180. I hope this makes sense. If it is positive, it's fine. It's just the reference angle we're done because it's in the first quadrant. But once I see a negative, it's an obtuse angle. I cannot write 63,43. It's not even making sense. My angle is bigger than 90. So it becomes an obtuse what? Angle. Did this make sense to you guys? So this is the new thing we've learned today. Every other thing we've done from point 1 to point 5 is actually grade 10. The only new thing now is part. Please let me know if there's any question. Let me know if you are okay. Give me a thumbs up. If there's a question, please, this is where we ask. Everybody is okay? You okay, everybody? All good? No question? Okay. Now, I'm going to give you a question, and we're going to walk step by step together. I want to make sure that we're good. Right. So let's see how an examiner will combine this for us and tell us to look for an angle maybe. Let's look at this. So we're going to have a y-axis, x-axis. Let me use green to draw my coordinates. So let's have a positive gradient. Let's have a negative gradient. And let's complete it in a triangle. Ooh, lovely. Right. Okay, I'm going to call this. I cannot call the other one theta. I'm going to call this alpha. Right? Then I want to create an angle here, and I'm going to call it beta. So this is how they are going to combine all of these things for us. Okay, so let's create our coordinates. Let's call this negative 9, 12 there. Let's call this negative 3. Let me use the same one I used earlier. And let's call this C. All right. There are, if you look at this diagram while you are drawing, there are only two angles of inclination here. There are only two angles of inclination. In this case, theta and alpha are our angles of inclination. Why? Remember, we are measuring from the x-axis. Beta is not an angle of inclination. Let me know if what I just said makes sense. That there are only two angles of inclination, which is theta and alpha. Beta is not an angle of inclination. Why? Because it is not measured. You see, this one is coming from the x. Angle of inclination always from the x. All right? All right, guys, please watch. Now, I want you to look at this. We are going to apply the rule of a triangle. We apply the rule of angles in a triangle. I want to extract this triangle out for you. There's a triangle there that I want you to see. All right? There's a triangle there that I need you to see. I'm looking for beta. Right? I am looking for beta. Now we can work with exterior angle of a triangle is equal to opposite interior. We can work with sum of angles. So we are going to work with the rules of triangle, two of them. Either we say sum of angles in a triangle, or we work with what? Exterior angle of triangle equals to sum of opposite interior. You've got to find a way of seeing that. To find a way. That. But anyway, let's work out the solution, everybody. I will take you step by step. Step one, and that is what you are going to do for me. Please get involved. Find theta. Step two, find alpha. We've done those two. One is a positive gradient. Let's start from there. The other one is a negative. So go back to your note. How to find it? First, we find the gradient, then we use tan theta. So come, let's walk through. I'll be waiting for you. Find theta. Let's find alpha. Guys, let's work out the first one quickly. Step one. Share your answers.
It's 56,31.
20?
56,31 degrees.
56, okay, 31. Let's work, I want to get answers from everyone now. We already have an answer to work towards. Don't know if it's correct, but let's work towards it. Everybody, we need to confirm. Eric, what's your answer? You just said it's correct. What's the answer? You get. (6.31). Given, please, I'm worried about you not giving me answers quickly, so I need to make sure when Junaid fall back and just copy answers and tell me that's what you got. No. Given, what's your gradient for BC? What did you get as gradient of BC? Yes, Tariq, we have to use that. Given, quickly, please, you gave me 56.31. What is your gradient? Make sure that we're working it out and we're just not going other people.
So is it possible to have a negative?
Negative what?
A negative degree, because I said I got my gradient as -7/2. Then I punched the if you press shift on the calculator and tan, the tan -1, then bracket -7/2 give me -74.05. Is it possible to have a negative?
Mandla, please quickly look at the example we just did. Look at example 6b when we got a negative gradient. Quickly look at it. I'm not going to get a negative angle. Quickly look at the steps that I did there. Given you're giving me 1.5 as your angle, as your gradient. You're sure it's 1.5? That is 18/12. All right, perfect. Okay, guys, workout number 2. Tariq has already given me an answer that we can look towards. He's giving me 105.95. Tariq is giving us something we can work towards. Look back into the notes. While I'm quickly working out step 1, be ahead of me now. Y value of B, X value of B is -3, and theta, gradient of BC, arctan of 3/2. Right. You guys gave me what, 56? Was it 56.31 for the first one? All right. Okay, second one. Second one. What is the gradient of AB? YA minus YB, A minus XB. What is the Y value of A? 12. Y value of B, -9. Can you see it's a double negative? X value of A is -9. X value of B. Right, what is this giving you, everybody? Somebody help me with, oh, -7/2. You guys gave me that. Lovely. Now, I told you that we don't put that negative. Our reference angle, arctan, what? Remember, we said tan, we need this formula. Now, it's not theta now, it's alpha, gradient of AB. So tan alpha gives 7/2. But we don't put the negative. That's the note that I gave you. A reference would be the arctan 7/2. I think Tariq gave me an answer there. Tariq gave me 74, what? 05. But then we said it is in the second quadrant. So we say theta is 184.05. Mandla, we okay now? (105) must be an obtuse angle. There we go. There we go. All right. Our job now is to find beta. Beta is in a little triangle there, and I wanted to see something. There are two ways of doing this. Analytical, a bit of Euclidean geometry. Do you notice that we can talk about vertically opposite angle there? This angle is also theta. I hope you guys remember vertically opposite angle. So we have a tiny little triangle, and this is where I want you to please watch. We have a tiny little triangle. I'm going to draw it here because I want to draw your attention to it. Look at this. Where this is theta, this is beta, this is alpha, and this is beta. If you can see that triangle there. You see, I've drawn my theta now into the triangle. All right? Oh, sorry, it's alpha. Thank you. It's alpha. So I have now taken your attention to this triangle here. Guys, can you see this triangle? Let me know if you can see this triangle that I drew there. Can you see it? Can we all see it? I can use some of angles in the triangle, but I'll need to find this other angle. But I don't need that. As mathematicians, we should know that the angle outside, alpha, is equal to beta plus theta. That is using exterior angle. This is an exterior. Please label it. Exterior angle is equal to sum of opposite interior. We'll do it in two ways. Since I now remember that theorem, I can say 105.95 degrees equals to beta plus, what is my theta? 56.31. Therefore, what is our beta? That over to the other side, 105. This we need to repeat. Right, you will see this in a question. Virtually in every grade 11 question. 49.6. (49.64 degrees). Exterior angle. Another way is to find this inside angle, but it's a long process. It's longer. Please write this quickly. I'll do the other method, or do it longer, but I'll do it here. I'll use a green marker to do it, green ink to do it, just for you to see. One is going to force you to use exterior, but it's just shorter. We are mathematicians. No, this is 56.31. Let me make it bigger. I just want to keep it on this page. All right, I'm sure you guys are done. I want us to work the other way around. Tell me if we are ready. All right, so if I want to use that triangle, I'll have to work with angles on a straight line first. It means I can get this angle, which is not labeled. So I can label it as, what can we label it as? Alpha 1, maybe. What is alpha 1? Angles on a straight line. 180 minus 105.95. Would that be? Angles on a straight line. $70-something. Somebody giving me an answer? 74.
74.05.
All right, thank you, Mandla. And then we can use sum of angles in a triangle. Beta plus 74.05 plus, can you see this one is a bit long? But it's okay, no one is forcing you. Can we confirm that answer? Use your calculator. Are we still getting 49.64? Sum of angles in a triangle. It's still giving us that answer? Oh, Tariq says yes, Ponolo says yes, Mandla says yes, because you just need to move everything over. All right, so that's just basic geometry. Guys, everything we have done so far has just been on gradient. That's how important gradient is. Everything we've done so far has been on gradient. Let's add maybe 3 more points to analytical geometry. So number 1 point we looked at is gradient. Positive gradient, negative gradient, undefined gradient for vertical lines, and horizontal lines have a gradient of 0. Then we looked at 6 points. Formula of gradient, equation of a line, parallel lines, collinear lines, collinear points rather, perpendicular lines, and the angle of inclination. Please, I just want to try to see as many concepts I can look at. You need to sit down, please master this, because when we pull up questions together now, I'm going to... Can I move forward? Can we move on, everybody? Okay, now quickly, let's look at the next concept. So we said number 1 was gradient. Concept number 2. Let's look at distance formula quickly. Let me use capital. Distance, or what we call the length. It's just a formula, there's no need to worry about this, so this one is very fast. The longest one was that, so distance equals to the square root of x2, x1 squared. To substitute, that's all. Great. We just substitute. Let's find the distance between A and B. So I just want to copy 9, 9, negative 3, negative 9. Right. Please find me the distance between AB. What is the length of AB? So if they don't use distance, they will say length. What is the length AB? Quickly, just substitute, my good learners. I hope you guys are not waiting for me. We should be able to get an answer. This is also grade 10. And we are only substituting and using a calculator. That's all. Quickly. I need answers. Leave it as search form. You don't need to give me as decimal. Leave it in search form. Come on, guys. Even if I'm not using a calculator, I will be done. Iyad is giving me 21,63. Can I get more answers, please? 6 root 13, 21,63. Given, Junaid, are we stuck?
So I just forgot to put the squares.
Then there's going to be a problem there. All right, so AB, I like to use my X and A and B. I'll say XA minus XB squared so that I can quickly see which one is A and which one is B. It just helps me. So I have the square root of, what's the X value of A? Minus 3 minus X value of B is 9. What's the Y value of A? Y value of A is 9 and the Y value of B 9. Right. Is it 6 root 13? Let's confirm together. So you mustn't forget the squares. That is 12 squared plus 6 root 13. Well, okay, you can leave it like that, except the examiner wants you to put it as decimals, and we must know how to round off. 12,63. Thank you, guys. All right, done. 2 more things for the night. 2 more things. Midpoint. Midpoint simply talks about halfway. When we say mid, halfway. Right? Halfway. Capital M. X1, x2 over 2 y1 plus y2. Done. Midpoint means halfway. Means AM is the same as that. Can we use the same set of coordinates quickly? Because I need to show you something here. We're ready to clock out. Oh, we've done a lot today. A whole lot of work has been done. I wish you guys were not going to school tomorrow. Class tomorrow. We could have. But anyway, work with me here. Midpoint. You know, if you notice, analytical geometry is just you working around with the formula. The formula has been given. All we need to do is to substitute. Why are we losing network? Oh. All we need to do is to substitute. Can you guys hear me? Had a little glitch now. 1 second. Little glitch. All right, can you see me now? All right, Tariq is giving me 3 and 0, which I think is correct. So M is different from gradient. This is capital M. All right, no equal sign. XA plus XB over 2 YA YB. What is M? X value of A, negative 3, 9 over 2, YA, negative 9. Just to finish quickly. So, that is 6 divided by 2, which is 3 and 0. Done. Make sense, everybody? Just want to tweak this a little bit around. Want to tweak this quickly, and we are done. We just tweak this very, very fast, and we would finish. Is everybody good? Bonolo, I didn't see a response from you. Bonolo, are we good? Gavin, are we good? Mandla, Junaid? All right. Now, look at where learners usually miss this. Learners miss it somewhere when we are given the midpoint and we need to find the other point. Okay? Learners usually just throw that away. We are still on midpoint. Please check this. All right. A, B, C. Once I do that, it means B becomes my midpoint. Right? Now, if I know the coordinate of A, I'm using the same coordinate, and I know this as 3. Question is, I'm looking for X and Y. Please, I am going to use the midpoint, but I'm going to reverse the midpoint. What do I mean by reversing the midpoint? Just by analysis, quick analysis, B is the midpoint. What do I know? B, I would have gotten B by saying XA plus XC for 2, YA plus YC. So that should have been how I'd have gotten my B. That's the midpoint formula. But I know the coordinate of B as 3. Oh, beautiful. Look at, I'm just going to equate the x part, equate the y part, and I'll be done. So it means xa plus xc over 2 would give me 3. Is the value of xa? Negative 3. What is the value of xc? We don't know. So what do we have? We cross multiply. Move that over. Get my 9. Move to the next one. Ya plus yc. Be 0. Y value of a? Negative 9. What is the y value of c? Y cross multiply. Move that over. 9. The coordinate of c. Okay. Are we okay there? Don't write this one. I just want to put a little note of what we should be looking at when next we meet. I'm going to quickly revise the equation of a line. We're going to deal with gradient parallelograms. We're going to find the coordinates, point of intersection. Four things to look at, and then we will then calculate areas, perimeter of quads. These are the four things, so there's no need to rush up anything. These are the four things that we're going to look at, and that will be the end of analytical geometry. So we can finish this in our next session. We'll move together. So far, are we okay with what we did? Please revise, read the notes. Whatever we did here is needed again next year. So this note, this lesson is very, very important. This is question 3 of your paper 2 when you get to the week. If there's no question, please have a beautiful evening. Next lesson, we are done. We just then practice and practice and practice. Right. Thank you, and have yourselves a very beautiful evening, everybody. If there's no question, I'm still here waiting if there's a question. Good night, Bonolo.
Sir,
Yes, Mandla?
if, like, remember the grade the tan of theta is equal to MUV?
You want me to go back to that gradient? Where is it? Yep.
How do you know that the reference angle is 102?
Because that's where tan is negative. General solution. Where is tan negative? Do you remember your cast diagram?
Yes, I do.
Good. So we're saying all of them are what? Positive there. Sine is positive here. Tan is positive here. And what? Cos is positive. So
Yes, sir.
where is tan negative? Tan is negative in quadrant 2 and quadrant 4.
Okay.
But we don't need to work out 2 and 4. Look at what it really means. Look at it. If I were to draw a little Cartesian plane here, See that?
Yes, sir.
That this is quadrant 1. What is this?
2, quadrant 2.
Do you see where we are?
Yes, I do.
Good. 3 and 4.
So this, if I draw this as a Cartesian plane in the paper, would it work?
To draw what?
This is a Cartesian plane that you did on this land. Would it work in the exam if I tried it on a little piece of paper?
Yeah, it will. Why would it not? It will always work, but you don't need to draw it. Just remember, you would only have 2 types of gradient in this case, positive and negative, except you are not clued on general solutions.
Yes, sir.
So once I see a negative gradient, I know that I'm in my second what?
Quadrant.
And every time you're looking for your reference, please don't put the sign. Can you see?
Yes, sir. Make it a positive.
Good. The negative sign only gives you the quadrant.
Yes, sir.
And the reduction here is 180 minus ref.
For reference.
So that I need to get an obtuse what? Angle there.
Yes, sir. Thank you, sir.
Awesome.
Enjoy the rest of the night, sir.
You too.